Welcome to the new Supervise module video of eFlow 5. This video is going to present you how to work, use, and configure the Supervise module for your production site. First, we are going to talk about what is SLA, the main factor and feature that Supervise work with. Then we'll talk about SLAs in eFlow. We'll talk about why we need Supervise module in our production site. Then we will move to how to use Supervise module. We will show Supervise module demo so you can have a better understanding of the system. We'll move on to how to configure Supervise SLA. We can have more than one SLA in an application. Later on, we'll move to making decision using Supervise information, which is a powerful tool for us in order to manage the data processing of the site. We'll also show alerts, which are a type of notification, and how to configure them. And we'll finish with SLA assignment, which is a type of prioritization of the data that we are processing. At the end, we are going to briefly talk about some technical details that runs on the background. How does Supervise works, how does it collect the data, and how does it store the data. Supervise module is based on common term SLA, Service Level Agreement. This means a unit that will measure our performance according to a predefined time, speed, or quantity, or all of them together. If we are expecting to process a certain amount of data, the Supervise will monitor in real time how our processing tools are performing and will notify us according to calculation if we are going to process the whole amount of data in time, and if not, then we can use some additional resources to step up the processing speed and be on time to finish the whole data. It is a powerful tool for site managers to get decisions in real time. In eFlow, every application can contain one or more SLA, so we can actually define processing expectations according to certain rules and parameters that will apply to different types of data. We will turn on our Supervise module from the menu list. Here we get the initial screen for the Supervise module. We can see different tabs and different views. SLA tab, operators, stations, reports, and alerts. In order to simplify things, we'll start with the SLA view. We will choose from the application our application, Supervise Demo. We can see a default SLA that is defined for this application. Every application initially starts with the default SLA, and later on we can configure this default SLA, or we can add additional SLAs according to our needs and then configure them. Press the setting button on the right top corner. Here we get a list of all the SLAs according to the different applications. We'll browse to our application, Supervise Demo, and we can see that we have already a default SLA created by the system. We'll choose New to create a new SLA, and then we'll fill in the appropriate parameters to define and configure our SLA. First, we give a SLA name, give some meaningful name so you will understand it later on, and choose the relevant application from the application list. Then we have the SLA type. This is the main time measurement for data to be processed, and it is the frame of time for all the parameters to be measured. There are two SLA types. Fixed time, the first one, usually for shifts production sites, where there are fixed starts and finish times. If selecting this option, you can also select a recurrent of the measurement, by daily or by weekly recurrence. The second type of time is time to complete. This is a certain amount of time measured by seconds, minutes, hours, or days, and is starting when the first collection that enters the system is linked to the specific SLA according to a set of rules. In this case, the time measurement will count down until the last collection that is linked to the SLA has left the system. If additional collections belong to the certain SLA has entered the system while their collection belonged to that SLA still in the system and did not leave it, the time countdown will continue. Only after the last collection that belonged to the SLA has left the system and new ones will enter, the SLA time measurement will start again. This parameter of time frame is important, and all the calculation of the system will be according to the time frame. And then it will show the manager of the site if we are doing on time or if we are performing less than the time requires. For our SLA, we will choose to measure by minutes, time to complete, and we'll give 20 minutes. CPM is collections per minute. How many collections per minute we're expecting to run in our SLA from start to end, from start of the measurement of the SLA until the end of it. Pages per minute is how many pages we are expecting per minute to run in automatic stations only. Again, it's a measurement that will help us to take decisions. And quantity. Quantity is the number of collections that we're expecting for the life cycle of an SLA. An SLA life cycle starts when the first collection enters the system and linked to the SLA according to the certain rules until the last collection that belongs to the SLA leaves the system. The quantity is the number of collections that we're expecting in this life cycle of the SLA, and the measurement is done accordingly. Pay attention. The quantity and the speed of collections per minute can calculate how long the SLA needs to live, which is the duration that we can see above. But actually, these are two types of different dimensions. The duration is usually longer than the calculation of speed multiplied quantity because usually collections do not enter all of them, all the collections that are defined in the quantity, in a single time into the flow. Usually while scanning or while importing by file, collections are loaded into the flow continuously in different time positions. This is why we have two types of measurements, and the measurement is done without any relation between these two dimensions. We will set the quantity of collections in our SLA to 20 and continue. We will now define the export queue. The export queue is the point or the station where the SLA finishes. You can finish the SLA at the last station of the flow, which is out, or you can finish the SLA at any certain different type of station along the flow, and from there onwards you can also define a different SLA. We will choose out, which is the final point of station in our flow. Now we will select a caller for our SLA. This will be useful later on when we use SLA assignment. We'll choose a flow, and then we will choose the rules that will define which collections that will enter the system will belong to our SLA. These rules are based on the meta tags that each collection carries with it, and you can use the default ones that are created automatically by the system, or you can also create your own meta tags and use them in the rule list. You can use one rule or multiply rules, which are evaluated by AND condition. Bear in mind that rules must be unique per SLA, and no rules can overlap between SLAs. Otherwise, the batch will not be able to be linked to any certain SLA and might cause some linkage errors. Also bear in mind that if different rules from the different SLA do not apply to a specific collection, this collection will be linked automatically to the default SLA. Later on, if the collection meta tags values will change, it might be linked to a certain SLA where rules were applied. Collections may also change their linkage to different SLAs along the workflow if their meta tags values has been changed. We'll press Add to add a rule, and we will choose a meta tag from the list of predefined meta tags. In our case, we are doing supervise small collection SLA, so we'll choose meta tag of number of pages equal or smaller than 10 and press accept. You can also edit or delete a rule. We'll press OK to accept all SLA configuration parameters. You can see that the SLA has been added to the SLA lists for our application. We'll define another SLA, this time for supervise large collections. It will be quite similar to the previous SLA, but with slight differences to cater for large collections. The time frame will be the same time frame, 20 minutes, as before, but the collections per minute and the pages per minute, obviously, since these are large collections, will be lower measurement. The quantity will also be half, only 10 collections per SLA, and the export queue will be the same one as the last and final point or in the workflow. We'll choose a different color, we'll choose a flow, and we will add a certain rule that will cover for these types of collections. In this case, we will use the meta tags, again, of number of pages in the collection. This time should be greater than 10. And we'll press accept. This covers the full picture of collections that we are going to run on our system. Now we have 3 types of SLAs for our supervised demo application. We'll go back to our previous screen. Now we are ready to start running our application and examine how the SLA are going to work. Let's turn on the stations. We'll turn on File Portal and we will import few batches that will be relevant for both types of SLA, small collections and large collections. Bear in mind that the SLA starts to be linked to collections when the meta tag value is determined. In this case, we are linking our collection using a meta tag that is number of pages, which means that when the collection will be created, it will be linked to one of the 2 SLAs that we defined. We'll send the batches. And we will verify in the controller that the batches start to arrive. Now we can see in our supervised main screen how the SLA is behaving and the linkage between our collection to each one of the SLAs. Back to our main screen, we can see that both SLAs have started to perform, supervised small collections and supervised large collections. On the top of each SLA, we will see the number of collections that belong to that SLA on the roller out of the whole quantity. In the case of supervised small collections, we can see 8 collections out of 20 that we defined in the quantity, which makes up 40% of the total quantity that we are expecting for the time frame for that SLA. On the left side, on the supervised large collections, we can see that we have 6 collections out of 10 that we defined for the quantity of that SLA, which makes up 60%. The planned time to complete has started to run and to count down. In this case, we put 20 minutes for both SLAs, and this 20 minutes has started to count down since this is our planned time to complete in our time frame. On the left of it, we see real time to complete. In the meantime, this real time to complete is not calculated yet because no batch has started the SLA and left it. Only when the first batch will leave the SLA, the system will be able to calculate how much time it's estimating for the rest of the batches to calculate it according to our performance. This time is one of the most important parameters, and by that we can calculate and measure and estimate if we are going to perform and process the whole data on time according to the time that we defined. Moving clockwise, we can see below the number of collections that belong to that SLA. In the case of supervised small collection, this is the same 8 collections that we can see on top where the roller is. And in the supervised large collections, 6 collections belong to that SLA. Pay attention that this number is updated in real time. Next to it, you can see the number of collections that were sent to reject queue for any reason, so it's a type of notification, and the number of batches on hold. Continue clockwise, we can see the performance for time, the performance per minute, for collections per minute, and for pages per minute. We can see the planned time that we defined for pages per minute and collections per minute. The real time for pages per minute and collections per minute has not been calculated yet and is shown as 0. This will be calculated when the first collection that belongs to the SLA will leave the whole SLA and will be updated in real time according to our performance. Also pay attention that the default SLA is empty and no batches were linked to that SLA since no conditions were found to be linked to that SLA. After we've understood about the view of the initial SLA parameters, let's turn on some additional stations and see how SLA behaves. We'll turn on all the rest of the stations in the workflow, and let's start to process some batches. We'll turn on the recognition station, the validate station, and the export station in order to complete the full functionality of flow. So we'll have a full flow for our collections to be processed. We'll get a collection in validate station. As you can see, there are some collections already waiting for us in validate queue. The collections are of type with 8 pages, means small collections SLA. We'll process some collections, 1, 2, 3, 4, 5. Let's go back to our supervise and let's verify. Soon the details will update. We have 8 collections that are linked to that SLA. These 8 collections 5 of them has been moved to an export station and has been exported automatically. So we can see that the details are starting to update. First of all, you can see that the total number of collections linked to that SLA is reduced to 3 from 8. Secondly, you can see the roller of the quantity of collections at the top of the SLA, in the small collection SLA, has turned into green. This means that the quantity of collections that are linked to the SLA currently will all be processed in time, according to the time frame that we have defined, if we will keep the same performance and speed of processing that we have done until now. We can also see that the real time to complete has also been updated. Currently it's 0 minutes, means that if we will keep the same ratio of processing, we are going to finish the quantity of collections, which is 3, that's still linked to that SLA, within this amount of time, means less than a minute. If we will wait, slowly this number is going to raise until it will go above the planned time to complete. When this will happen, the roller will turn into red again. We can also see that the real pages per minute and the real collections per minute has also been updated. And if you take a closer look, you will see that in real time, this number is also updated according to the speed calculations. Since we are not working anymore on validate and we are not processing the collections anymore, this number is slowly reducing until this will reach to a point where we will not be fast enough to work according to the time frame that we determined. Now let's continue to process more collections. We'll process a collection of 8 pages from small collection SLA and one collection from the large collection SLA. Let's look at the details. You can see that the number of total collections in SLA supervised small collection is reduced to 2. And if we wait a bit, we'll see that the number of total collections linked to the supervised large collection SLA has reduced to 5 from 6. We processed one batch. So now it's the point of time where the details are starting to update. You can see that the roller of quantity of collection has turned into green. It means if we'll continue with the same ratio, we are going to process all the quantity of collections that has been left within 1 minute. Take a look at the real time to complete parameter, and that is in real time updated. Now it has gone up to 2 minutes. Still, it's less than 7 minutes 13 seconds, which means that we're going to process all the remaining collections on time. The pages per minute and collections per minute parameters has also been updated, and once we have started to export or process from start to end of the SLA any batch, these details are going to be updated. Since we are not processing any more collections, these details are slowly reducing. And if we're going to wait a few more seconds, we will see that the collections roller has turned red again, since we are not performing any process of any collections. The time that is going to take us, according to the speed and the performance that we used until now, going to get higher than the time to complete that we defined for that SLA. So the roller of all the collection has turned into red, which means we have to start processing collection. We have to start tackle our bottleneck of collection. We are going back to our validate station where the collections are lying and waiting to be processed. Once we process all the collections, we turn back to our supervised main screen. We'll wait a few seconds for the details to be updated, and as you can see, the number of collections that are linked to that SLA is reducing, since they are already, all of them are exporting. The roller has turned into green, which means that we're going to process all the remaining collections on time. And now we can see that the total number of collections for supervised large collection SLA has reduced to 0. We have finished processing all the remaining collections for that SLA, and the calculation of pages per minute and collections per minute has been updated, and we've finished our both SLAs. You can see from our brief demo, the supervised module is giving you a real-time picture of the performance of your workflow, and is showing you along the time, the expected and the actual speed and time of processing the rest of your data. By that, the site manager who uses supervised module can get decisions about usage of resources, and when alerted, can manage all the aspects in order to complete that data processing on time. Unlike the controller, which only gives you a real-time picture of your load in the different workflow modules and can indicate bottlenecks, the supervised module calculates the performance of your processing work and compares it to the planned one, and in real time shows you the expectations for completing the data and the remaining time frame. Not only that, the site manager can make use of another powerful tool of the supervised module, which is alerts. That is a notification shown on the supervised screen or sent by email for a predefined set of different scenarios and situations. Once a scenario has turned relevant, a notification will appear. Let's see how to configure that. On the top right of the screen, go to Settings. Here we have a list of our SLAs. Go to Alerts and open the Alert configuration screen. Here we have a list of alerts on the left side, and we can configure each one of them if to activate and if to send the alert by email notification or only to show it on the Supervise module screen. Each alert is referring to a different scenario. We have the default alert to activate by default all the alerts and to send email notification parameters to all the alerts, or we can click on each one of the alerts in order to configure it separately. In the list of the alerts, we've got CPU alert. If the CPU of the server or one of the clients is higher than 80% for a time frame of more than 10 minutes. We got an alert for the rejected station if any collection arrives at the rejected station. We got an alert for behind schedule if we're not going to complete the data that we have in our SLA on time that we defined. We have an alert for license expired. If 2 weeks before the license expiry we did not extend the license, it will highlight an alert. We have an alert for queue empty. When a queue of an automatic station is empty after it used to process already batches before for more than 10 minutes. We got queue load alert if the load of a queue is accumulating and the processing time of batches cannot keep an update when batches and collections are accumulating in the queue above a certain ratio. And we have a move to queue alert, which means you can determine a certain queue where the alert will highlight when collections will arrive that queue. For each one of the alerts, you can separately configure if you want to active the alert, and you can also specify separately email notification, email configuration when you want an email to be sent for each one of the alerts. The move to queue alert is the only one that you can configure certain parameters like the queue that will be moved to. The alerts are shown on the top right of the Supervise module screen. They are categorized into 4 different types of alerts: performance, workload, resource, and IT. In the performance, we can see that we have one active alert. This alert is behind the schedule alert. Once you click on alert, it will take you to the alert screen, or if it's an alert related to a station, it will take you to the station screen. We will now import more collections to the workflow in order to examine the alerts. In the Supervise module screen, we can see that we have one alert from workload type. This alert is a move to queue alert. It means a collection arrived to a queue that we defined as a queue to notify an alert. If we go to the alert screen, we can see the alert type, move to queue, and which station queue it is highlighted from. The alert is active as long as the collection lies in the queue which is relevant for the move to queue alert. Once it will get out of the queue, the alert will turn off automatically. We are turning on our recognition station, and this will process our collection that is waiting in the queue. The collection has ended processing. We'll go back to our alerts screen. In the meantime, another alert has joined our alert screen, queue empty, for an automatic station. In this case, it's an export station that was idle for more than 10 minutes after it was active. Now we can see that our original alert, move to queue alert, has been gone from the list since the collection is not relevant anymore for the alert. You can click on each alert and press navigate on the top right of the screen in order to get more details of the alert. We will click on the queue empty alert and it takes us to the station screen. In the station screen we can see the export station that was idle for more than 10 minutes. And we can see the details of the stations like pages per minute, collections per minute, usage, and load rate. We can also remove an alert from the list, even if it's still active. And the list now is empty of alerts. An alert will be shown again only if relevant collections are processed in the SLA and the notification should be alerted. We'll go back to our SLA main screen. In order to examine better the situation that is going on in our site, the Supervise module is giving us more tools in order to get more details about the scenarios that are in real time happening. One of these details is the station view. We'll activate some stations in our site. In the meantime, we can see that we have another alert, which is an IT type of alert. Usually it's CPU high when CPU is high. When we are moving to the station view, we can see the list of the stations that are activated in our site. And for every station, we can see the details of it. In order for us to get a better understanding of what's going on in our site and to improve the efficiency and the processing time in our site. Pay attention that each record represents a station and not a queue. For each station, there are some beneficial details to know. Pages and collections per minute, usage, how busy is the station processing our data, load, what is the current load in the queue of each type of station, and load rate. What is the rate between income data and outcome data? If the load rate is too high, it means we need to turn on additional instances of that station. If the load rate is too low, we might turn off some instances of that station and maybe instead of that turn on other type of stations. In the station view, you have the option to log out a station from remote, to assign a station on a certain computer, to duplicate an existing station, or to run a station like unattended station auto run. If we choose to run a station, we get the automatic station assignment screen. We can choose the station type, the number of instances we want to run remotely, and which machine name we want to run the station on. We can also apply to all the stations. Another smart tool that we have in the Supervise module is an allocation of resources according to the specific SLA. As we mentioned before, an SLA is a linkage between collections that all assigned to according to certain rules. We can assign different resources, which can be type of a station or type of operators or groups of operators, according to a certain SLA. This is called SLA assignment. From the settings screen, choose SLA assignment. Here, browse to your application, expand it, and here you have assignments per queue, operator teams. If you choose a queue, you can choose a certain station or all the stations. We will choose to allocate resources for validate station. Here we are selecting our resources according to the different SLAs in validate station. We can choose by percentage the number of collections that will be processed for each type of SLA. This means that if we will choose 100% of the collections to get from a certain SLA, all the typists that will work in validate station, when pressing get collection, will get collections from that SLA. If in the queue there will be no more collections of that SLA and only of other SLAs, they will be get automatically from other SLAs. As long as there are collections from all types of SLAs lying in the queue of that station, the ratio according to the specific SLAs will be taken from the percentage. You can use the locker beside each SLA to lock it and then to play around with the remaining SLA percentages. We will go back to our validate station and we'll allocate the resources according to 30% of the resources to supervise small collection SLA and 70% of the resources to go to supervise large collections SLA. We'll turn on the validate station and we'll start processing collections. Our first collection is of SLA small collections because it has 8 pages. The second one, 16 pages. The third one, 16. The fourth one, 8. The fifth one, 16. The sixth one, 8. The seventh, 16. The eighth, 16. The ninth, 16. The 10th, 16. The 11th as well, 16. The 12 also 16. And the last one, the 13, 8 pages. So we can see that even when our queue was loaded with batches from all types of SLAs, the resource allocation was taken from the allocation that we just configured per SLA, and not by any type of random or other prioritization. Another possibility is assigning an SLA according to a user or a group of users. As we can see, below our queues assignment, we can have operator teams. Let's see how to define and use that. We'll go to users and we will create a new team and then list of operator under that team. Press new team, rename it, and add all the operators under that team. You can define the operator user as a domain user or as a workgroup user. You can add multiple users. And press OK. We'll go back to our SLA assignment. We'll browse to our application and to the operator teams. Here we can find our team and we can set the SLA resource allocation according to that team. We can also specify it even at the specific user level. So certain users can allocate resources according to the SLA. After we've shown all the supervised configuration and uses, we can see some technical stuff behind the scene. Go to your SQL server and we'll turn on the Management Studio to see how the Supervise is working behind the scene. We'll connect to our instance and we'll browse to databases. Here we can see the monitor database where the Supervise stores all the details needs for the Supervise activities to perform. Another use of the Supervise behind the scene is the auto-run service. The auto-run service is running on all eFlow clients, and this is the service that collects the data from the clients and send it to the server to be collected in the monitor database.